So in this problem, we have to calculate the vapor pressure. We're actually not calculating the vapor pressure of the solution, but we have an ionic solute. We're going to be dealing with vapor pressure, and we have to calculate the number of moles of sodium chloride in the solution. Sodium chloride is the ionic solute. So I want to just say out here, I'll write that in green out here, that sodium chloride is NaCl and it dissociates to give Na plus and Cl minus ions. And what that means is 1 unit of sodium chloride gives us 2 ions, so 2 species, let's call them species, in solution, okay? And we're going to keep that in mind for a later part of the problem, okay, when we have to figure out the number of moles of sodium chloride in the solution. Okay, so the solution contains 0.115 moles water and an unknown number of moles of sodium chloride. The vapor pressure of the solution is given as 25.7 torr. The vapor pressure of pure water is given as 31.8 torr. So the first thing we're going to do is we're going to use Raoult's law, and we're going to write the vapor pressure of the solution is equal to the mole fraction of water times the vapor pressure of pure water. So we'll plug the values in from the problem. So the vapor pressure of the solution is 25.7. We'll put that in here, 25.7 torr. We're solving for the mole fraction of water, so we'll keep that as is. And the mole fraction and the vapor pressure of pure water is given as 31.8 torr. All right. So if you solve for the mole fraction of pure water, you get 25.7 torr divided by 31.8 torr, which is equal to 0.8081 torr. Okay, we're going to keep one additional digit because we're not rounding yet. All right, so the next step is to kind of set up the formula for mole fraction, knowing that sodium chloride dissociates into 2 species. Okay, so the way you set it up is we're going to say, well, the mole fraction of water is the number of moles of water over the total number of species in solution, right? So that's going to be moles of water plus, notice carefully, for every sodium chloride unit in solution splits into 2, right? So therefore you're going to have 2 times the units, 2 times the moles of, let me write that a little differently, 2 times the moles of sodium chloride. Okay, so, and let's, for the to solve this problem, let's call that X. So then let's go ahead and plug the values in. So the moles of, that shouldn't be torr, that should just be, that's the mole fraction, so there's no units out there. So the moles of water is 0.115. That's given to us in the problem up here. We're going to drop all the units because they all kind of cancel out, with the exception of what we're trying to find out here. We're going to put the 0.115 at the bottom plus 2x. And to solve this problem, we're going to just flip this, put the 0.8081 over 1, and then flip this whole thing on its head. So when we flip it on its head, we get 1 over 0.8081 is equal to 0.115 plus 2x over 0.115. And then we multiply both sides with 0.115. Those two go away. And then the left side simplifies to 0.1423. And the right side is 0.115 plus 2x. Subtracting 0.115 from both sides, we get 2x is equal to 0.0273. And then we have to just divide both sides by 2. So we get x is equal to 0.01365. And now we have to stick with the right number of significant figures. So it turns out, since we did a subtraction out here, okay, we really have to stick to 3 decimal places. So sorry, so we have to stop at the 3 out here. So therefore x is equal to 0.014, and that is the moles of sodium chloride in solution. I hope that made sense. Thank you for watching.